So before I talk about Lab 2, I wanted to jump into the schedule. I forgot to mention on Wednesday the craftsmanship meetings. So those are coming up. Those start Friday and they go until Wednesday. So you only have a couple days to do it. So the point of them, read over this. But the point of them is essentially just to learn from each other, especially the first lab. Some of you might be more familiar with C, others of you might be less familiar with C. So learn from each other. See what was a challenge for you. Maybe was it not a challenge for someone else? Get helpful hints from other people. So it's a time for you to meet together as a group to discuss problems that you faced. So I'll be posting the groups real soon in teams, and that's what you'll meet. You'll be meeting with them 3 times throughout the semester. This is the first time to get help with Lab 1 and to help with Lab 2. And then we'll have it again when we transition to Python, in case for some of you that might not be as familiar with Python, others might be. And then a third one at the end of the semester leading into the last lab, because that's a challenging lab as well. So yeah, like I said, read over this. But at the heart of it, I just want you to meet together 30 minutes to an hour, honor system, but meet together as a group. And you can talk about it wherever you want. I have some suggestions, some things to talk about, challenges you faced, bugs you faced, things like that, how you dealt with complexity. But the important thing is I want this to be done in love of, spirit of love and acceptance. So it's not a meeting to show off how awesome you are, how smart you are, or why everyone else didn't do as good a job as you did, right? We're doing this out of love and to support each other. And so if I get feedback that this is not a positive thing, then that, we'll have to stop it or there'll be, penalties for that. So please be, accepting, loving, show each other, how to do stuff out of respect and kindness. But hopefully it's a good experience. Let me know if you're like, this is a waste of my time. I'm still going to do it for the rest of the semester, but for future years, I can fix that. But I've got good feedback that people like this. But let me know if it's not really fulfilling what you think it should be fulfilling, then let me know how we can change it or adapt it. So that's it for craftsmanship meetings. So just meeting as a group for a half an hour to an hour sometime between Friday and Wednesday. And then it's just a learning suite, I think, exam, and you just say, yes, I did this. And then maybe you'll leave some comments or something like that. I can't quite remember. So that's it. Do it. I'll post the groups on Teams soon. Okay. So that's it for craftsmanship meetings. Let's move on to Lab 2. So like I've said a couple of times already, Lab 2 is probably one of the more challenging labs. I think from the time perspective, it's the longest lab besides the last lab. It's really not intended to be like that, but just all the concepts we add in this lab, it adds up to be kind of challenging. Conceptually, maybe not that challenging, but implementation kind of challenging. I have given you 2 weeks. If we go back to this schedule here, got from Friday to 2 Fridays from now. So you have 2 weeks to do this. I would start this sooner rather than later because you might run into some bugs that take a couple of days to figure out. If that's the case, come talk to me or Bryson. We want to help you out with these things. We don't want you to suffer with a bug for like more than a couple hours. But so you do have plenty of time to work on it. So please do work on it little by little. The heart of the lab is really the same as Lab 1. It's the same protocol, but we're making the transition from what, when we talked about HTTP, that the transition made from non-persistent to persistent. So we're making the same transition here from our Lab 1, where it was, one request, one response back, and that's it. You have to set up a new connection if you want to do it again. Here, we're going to now add multiple requests in one connection. And so that from that falls out some interesting problems. There's another word for this is pipelining. Pipelining is an important term in computing. I got a good link here to Wikipedia on it. You might have encountered this before, but pipelining is, you do this all the time. The example that everyone likes to use is washing your clothes, right? It's like without pipelining, you would take your clothes, put them in the washer and let them finish up, then put them in the dryer, let it finish up, and then fold your clothes and then put them away. And then if you had another load, you would just do the same thing over again. You'd wait for the whole pipeline to finish, the whole process to finish. But pipelining is say, well, once I'm done with my load in the washer, put it in the dryer, but why don't I start my second load in the washer? And then while I'm folding my clothes, I'll have one load in the dryer and a third load in the washer. So you can be pipelining these. You can be using every part of your process, throughout the whole while you're finishing these different tasks. So that's used in computing all over the place. It's just a general computer engineering, computer science term, and so you should be familiar with that. We're going to be doing pipelining from a computing standpoint. We'll talk about that more when we get to TCP, the benefits of it, but the benefits aren't just intuitive in nature. Just why wait for to finish your first request to send your second one? Why not just send the first and the second if you know you have two? So that's what we're going to be doing. From the protocol standpoint, that brings up an interesting problem. You can't just, so you're sending me is going to be the same thing. Sending the server, you're going to send reverse 11 hello world. So it's going to be the same format there. But now when I respond back to you, I'm going to have to send you the length of the response, because you need to differentiate between all of your requests. Let's say you sent 5 requests. How would you know when one request was, when I sent you back one request and when the other request was sent back? In Lab 1, we rely on the server to close the connection to indicate that it's done sending you data. But now that you're just pipelined, you might have sent 5 requests, and how do you know you got them all back? And so I need to send you now the length of the response. So I've added a new field, 11 in this case, 11 for hello world. So it's the length of the response back. So you're going to have to change your parsing a little bit now. Instead of just receiving it and printing it out, you're gonna have to say, okay, look, read the first couple bytes of data, say, okay, this is 11, great. Let me get 11 characters. Once I've got 11 characters, let me go and print those out. So what can happen, let's say you send these 2 requests back to back. In the response back, depending on how often you call receive, depending on how fast the network is, how fast my server is, you might get this response back. 11 backwards hello world, 11 uppercase hello world. And so you need to be able to pull apart these 2 requests. And so let's go systematically. You'll say, okay, give me 11, skip the space, get 11 bytes of data. And once I have those 11 bytes of data, process that response, and then go from there and say, okay, now I got, what's the next digit? Okay, it's 11. Okay, skip the space, get 11 bytes of data. So that's the protocol. The only change we made to the protocol is now my server, well, not the only change, but the change to the actual bytes we send is that my server now will send you the length at which it's responding. The other change to the protocol now is that my server won't disconnect. It is waiting for you to disconnect from it, because you might send more requests. I don't know, it just depends on how many requests you're going to send. So me as a server now can't know when you're done sending. If you're only sending 1 request, then I can know. But if you're going to send more than 1, then that could be a million, that could be a lot. And so I just have to sit there and wait. And so it's your job to say, hey, I sent 5 requests. I've got my 5 requests back now. I can close the connection. And then my server will say, okay, great, they close the connection. Okay, so that's the protocol. We'll talk about how to implement this in a second. We'll look at the code, or the template code. Okay, but let's talk about the command line, because now how do we put this in command line? We originally had an action and then a message, and there could be ways to add multiple actions and multiple messages, but that seemed too cumbersome. And so what we've changed to now is, instead of giving an action message, you just give a file. So now you're going to change your CLI to only take 1 required argument, a file name. And that file will contain a list of all the messages and actions. So example would be something like this. So it's uppercase, space, and then the message. In this case, hello world. Reverse, space, and then the message. Lowercase, space, the message. And so on. So each request is separated by a new line character. That's how you'll know that there's a new request. But other than that, there's no, or there's one other requirement, but you could have an uppercase, right? Uppercase, space, uppercase, and that shouldn't matter, because you'll just uppercase the word uppercase. So the space is really important, and so is the new line. The new line helps you know whether it's a new request or part of the same request. I think it's somewhere here in the requirements, but I'll get to it now. if you ever encounter a line that is badly formatted, then you in this lab should skip that line. You shouldn't exit out, you should skip it. So that'll be important. So what is a malformed request line? It would be a line that's just doesn't have a request or a valid action, a space, and then a valid message. I want you to think about that a little bit though, because that's maybe a little bit more tricky than you might think. What is really a valid line, but you'll have to be able to handle that. One more important thing, we talked about this earlier, the Unix philosophy. It's really important to be able to read from standard in. And so you're going to have to do this in this lab. It's actually really not hard at all, but you're going to have to read from standard in. And so if instead of giving you a file name, I give you a dash, like shown here, then that means read from standard in. Don't read from a file called dash, you name dash, read from standard in. So here would be an example of why you might want to do this. It's a little contrived, but you might cat out input.txt and pipe it to our program here. Because I provide the dash, it will read from standard in from this pipe and process the data just the same as if it was a file. So from your C program, it actually won't be any different whether you're reading from standard in or from a file. They actually both are file descriptors, and so it should be fine. Okay, so let's go over the requirements here. We've changed the port. I do want to highlight that. For every lab, we'll increment the port number. So we're now on port 8081. Previous lab was 8080. So make sure you update that in your code. Otherwise, you'll be talking, your lab 2 will be talking to lab server 1. You need to accept one argument. If that argument is a dash, then read from standard in, like I just discussed. Here's the usage pattern. It should be pretty much the same as lab 1 with a change of the arguments, but all the options should all stay the same as the required, the default value should all be the same except for that 8081. So we made this a little easier for you that you are allowed to send all your requests. My light turned off. You're allowed to send all your requests before receiving the responses back from the server. You don't have to interlace those. Just send your requests and then receive your responses. Like I said before, if a line is malformed, just skipped it. So a line consists of an action and a non-empty message. So non-empty, that's a good thing to know. If it doesn't follow that pattern, then just skip it over it. You must properly separate out your responses. So I don't want to see you print out just this right here, 11 space. You need to print out hello, the hello world backwards, and then new line, hello world uppercase. You can't just print out what you get from the server. You need to process it and parse it and break it apart and print it. And that will become a little bit more clear later on. Like I said, you must close the socket. I don't know when you're done sending requests. So you know when you're done sending requests because you've read through the whole file. And so it's your job after you've sent all the requests, received all the responses, to then close the socket. And then my server will close it as well. The last big thing, this is maybe a pain point for the lab, is that it can be any size. So I'll be testing this with the Book of Alma as an example. So that's the size that we're talking about, pretty large. So you've got to be able to handle that. That requires you to do things a little differently. In previous lab, you might have allocate to a specific size by using the square braces and create an array of that size. You won't be able to do that anymore because you don't know how big to make it. You need to use malloc now. Okay. It's always good to figure out how to test it. It'll be very similar to testing before. Make sure you look at these resources. These are helpful. Things like how do you grow your buffers? These are problems I ran into. How to read from a file and get lines from a file. This is an important one. We just talked about this on Wednesday, is how do you calculate the length of the string you're going to generate with the sprintf. You don't know how, it could be really big, and so you need to know ahead of time potentially how big it is, and so you want to calculate it before so you can allocate that accordingly. So function pointers, I want to get to that. Let's look at the code and talk about function pointers a little bit, because this lab also introduces the concept of function pointers, which might be new to some of you. Might be probably will be new to a lot of you, I guess I should say. So here's the H file. I guess let's go through the main. I think it's pretty boring. Yep, same as lab 1. It's just empty. And then this will be empty as well. So it'll be your job to fill this in, and main, same as lab 1. Okay, let's look at the H file. So here we have a config. It has the port, host, and now a file name. So a little different, but same idea. You'll parse the arguments. It will take, produce a config, or it'll fill in a blank config for you. Then you'll connect. The connect will use the host and port to know how to connect. Then you're going to send the request. This takes an action and a message. And then we're going to receive a response. And this takes a function pointer. Let me get to that in a second. Let's just go through all these. Then we have a close. So that's all similar to what we had before. The signatures have changed a little bit, but the functions are still the same. Now we have a couple extra ones, because now we have to deal with opening a file. So we have a way to open a file. So given a string, given a name of a file, open it. It'll return a file struct for you. Then we have this function called getLine. And then we close the file. So this getLine is important. It actually is going to follow almost similar, exactly the same as getLine the function does. So let's go to this function to see what it does. So getLine, you'll want to understand this pretty well, because this is essentially what you're going to be implementing. But given a file, it'll just get you one line. So look for a /r/n or /n or /r, and it will say, okay, here is a line. Here you go. That's great. That's what we want. So actually your your getLine, TCP Client getLine, will use this function's getLine to get you a line, but then you're going to break it up even more. You're going to break it up into an action and a message. So you're going to break it up even further. Not just a line, but an action and a message. Now this is not a typo. These are double pointers. I hate using double pointers. I don't know if you remember from 330, we tried to trick you with double pointers all the time and found it very convoluted. Here's an example where you actually do need a double pointer. There's no way around it. You need to have a double pointer, because essentially it's going to be a pointer to a string, and a string is a char star, right? So it's going to be a pointer to a char star. So it's a char star star. Wish I could avoid that. But that's just kind of how this is, how you design this. Okay, so this getLine will call getLine, get a line, break up the line, make sure if it's a malformed line, it will skip over it. But if it's not malformed, it will get the action, get the message, and return that back, or fill it in right here. Action message. Okay, so that's getLine. So your main function will want to open the file, connect to the client, read in line by line. When it reads it in a line, it's going to send a request, and it's going to iterate through that until there's no more lines. Then you're going to stop sending requests. Then you're going to receive responses, receive all your responses, and then you're going to close this socket, and I guess close the file. Okay, let's get back to this function pointer here. So the signature is very strange. I really don't like the C syntax for function pointers, but it is what it is. So a function pointer is like, what if we feel very comfortable passing data around. If I said this was an int, you'd just say, okay, I know what that is. If it's a char star, okay, it's a string or it's some kind of buffer. But how do you pass around code is maybe a question. Or how do you pass around a function? So that's done through function pointers. Python makes this way easier. It's just like any other variable. You can set any other variable to any other variable to a function name. C makes it a little bit more tricky. And so this is the syntax. It's saying, hey, we're going to take a function pointer. The function pointer is named handle response, the star right here. And this function takes in a char star. So it takes in a string and it returns an integer. So you need to provide in your main a function that takes in a string and returns an integer. And I describe what that should do here. Somewhere in here, what that means it should return. So what's going on here is when you call receive responses, response, you need to provide, like, what do I do with that response? So that's what that function pointer is going to handle response for you. So why do we need that? Why can't it just like print out the responses? And the reason for that is you don't know if you've sent tons of responses, you don't want to store all those responses until you're finally done. That's bad for two reasons. That's bad because it uses a lot of memory and a lot of time, but it's also bad because if the user was waiting for this, they want to see responses come back in real time. They don't want to wait for all the responses to be processed and then see the results. That'd be a really bad experience. So let's imagine for a second that you sent so many responses that it took an hour to process them all. Some crazy amount of time, or even 5 minutes. That's still a long time, right? To be sitting there waiting for something to happen. So if that was the case, without this function pointer, you would have to collect up all the responses for 5 minutes, and then at the end of that, you would print out all those messages. It's like, well, the user is going to be sitting there doing nothing that whole time. Wouldn't it be better if the user could be seeing as you got the response rather than holding it back until you got all the responses and print them all at once? It'd be better if you just print out one, and then you get the second one and print that out, and get the third one and print that out. So that's one reason to have a function pointer. Another reason, and maybe more importantly, is what if the response is gigabytes of data? You have to store that somewhere. Maybe likely in your memory. So you're gonna be holding on to this gigabytes of data, or even if you're smart and write to a disk, you're gonna be hanging on to it just to then print it all out at the end, and then you have to delete all that or reallocate that memory. It's much better if you say, hey, like, yeah, there's a lot of requests here, but I'm just gonna handle one request, print it out, and I'm done with it. I don't have to store that anywhere. I don't have to store it in some array or keep track of or save it to a file. I can just print it out, give it to the user, let them handle it, whatever they want to do with it, and then go on to the next one. So that's what that function pointer is doing, is it's a way to let the person that called your function get control once a response has been received. So your receive response is going to read from the socket. It's going to make sure it received enough. It's going to look at that, that decimal and say, okay, have I received 11 or whatever the number is? And it's going to receive those 11 bits of data. And then once it's done that, it's going to call handle response and pass in that string it received. And then after that, it's going to then check to see what was the return value of that handle response. If the return value, I forget, is 0, then that means to keep going. If it's a 1, that means to stop, or vice versa. You can read it in here. But it's also a way to help you know, have I received enough responses? Because you receive response, this function doesn't know whether you've received enough responses or not. It doesn't have any concept of that. It just has a socket, and that's it. And so it's just going to keep on receiving it. So it's up to you, the person that called this function, to pass in the code that knows when it's received enough. So in your main function, you're going to want to have some kind of counter, some global variable that's going to say, hey, how many valid lines did I read? And so you'll increment it for every line that you read, and then you'll decrement it for every time handle response got called. And once handle response got called enough, then you say, okay, it's done. I've received all my responses. Set this integer, the return value, to tell it to stop receiving responses. This is where I'd stop for questions, because I'm sure you'd have lots of questions, but you're not here with me right now, so we can talk about it on Monday. So it's a little tricky, function pointers, but they are worth understanding, and they're really powerful for the reasons I described, because they allow you to give control to the user right away to get responses back, allows you to not have to store all this in one place and have to print it all at the end, or process it all at the end. Just to be clear, this will be implemented in your main. This will not be implemented in your TCP Client.c. This will be implemented in main, and then in your main, you'll pass the pointer to that function into this function call. So if I bring up a new window to make this really clear, you're going to have some kind of main. I'm going to do this kind of pseudocode, like you're going to have, you're going to say like open file, and it's going to give you back a file, right? And then you're going to say, okay, like, line or action, no, I don't know, action, this is hard to do, in message in pseudocode, and then you're gonna say like, while, get TCP client get line, and then you're gonna say, okay, here is the file, and then here's my blank action and my blank message, something to this effect. This is not correct at all, so don't quote me on this, but this is hopefully going to give you kind of a rough feel for it. So while it gets those, then so if this returns properly, oh, look, it's going to auto-complete it for me. It's completely wrong, luckily. Let me turn off Copilot so it doesn't bother us. How do I disable you? Oh, no. Just for a second. Oh. Okay, whatever. So once this completes, we'll say, okay, we want to then TCP client send, is it send line? I think it's send request. Send request, and then here's the socket. We seem to have opened it, so let's TCP client, open file. Somehow it magically opens a file, then we're gonna have a socket, connect. Once again, this is pseudocode, so don't quote me on this. So you're gonna be sending these requests, cool. And at the end of this, you're gonna do TCP client receive response. And that's not right. It's gonna say we need some kind of function pointer here. So handle response, something like that. And then we'll do TCP close connection and TCP close file. I'd probably close the file first, but it doesn't really matter. Okay, so that's what it's gonna roughly look like. Of course, you want to do error checking. I'm not doing any error checking, anything like that. You'll want to do that. But what you're going to want to do is define another function. Remember, it takes an int handle response, and it takes in the response. And this is essentially what you're going to want to do. You're going to want to print out the response. Of course, this could be a lot more complicated if you wanted it to be, but for this lab, all you're going to have to do is print out the response. And then you're going to return some value. Of course, you're not going to just want to return 0 all the time. You're going to be smart. You're going to check to see, hey, have I sent enough? Has this been called enough? So you might want to have some kind of, int counter up here that we initialize as 0, and maybe we check to see if the counter is 0, and we'll like decrement it every time. No, decrement. Something like that, and then we probably want to increment it here, counter, something like that. So this is going to be your outline of your main, essentially. Is going to be connecting, opening the file, getting line by line, sending your requests to the server, and then receiving the responses. But this is going to block until all the responses have been processed properly. And this is what's going to be getting called. So every time in this function right here, every time you receive a full response, including, you're going to chop off the length of it, you're just going to get just the response, you're going to call this function. So it's going to get called magically behind the scenes. So you're never going to call this function directly. Well, you will when you write that code, but in your main, you're never going to call this function directly. It's only going to get called inside of this function right here. And this function tells you when it's done responding. And when it's done responding, this will exit out, and then you'll close the connection and close the file. Okay, once again, this is where I'd stop and ask if anyone has any questions. I'm sure people would have really great questions to ask. But we'll talk about it on Monday. So that's it for Lab 2. So the two big pain points, I would say, are getting this function pointer. It's actually not that hard once you get the hang of it, but conceptually it can be a little tricky, and hopefully this helped. But it's really in the receive response of having to grow your buffer. If you're going to allocate some space, and you're going to receive some data and say, oh, wait, this wasn't big enough. And then you have to grow your buffer. So I'd read over this, grow your buffer exponentially. It talks about how to use realloc and growing your buffer and all that stuff. You don't have to grow exponentially if you don't want to. That's kind of a performance enhancement. It's kind of a fun article to read if you're interested in why it's a good idea to do this. But you don't have to do that if you don't want to. But that's where the big challenge is how do you grow your buffer to fit everything in, and moving the pointers around in a smart way. We'll go over that later, but because you're going to have to put all the data in there and then move to the next part of the buffer that's been newly allocated so you don't override the old data in the buffer and all that kind of stuff. So a lot of pointer arithmetic, especially in your receive response. The other challenge now is because these requests can be quite large, like the Book of Alma, you won't just be able to get away with calling send once. So if we kind of, just separate this. So in your send function you wrote, I guess it was like, int TCP send request, once again, this is pseudocode, you may have just called send. You might have put together, you might have done something like, let's put together s printf, our %d, and then %s, and then %d, and then %s, and then something like that, and then it was an action. Yeah, sure, that's good enough. I guess you needed to have your dest or something like that, some kind of destination. Dest is some empty string or some array of some size, and then you called send on that, send dest, plus some other stuff. You need a socket as well, of course. So that worked fine for small buffers, but that won't work when the buffer is really large. So you're going to have to check to see what was the value of send. So like return value, and then you're going to say if, remember, we want to check to see if it's, if it was return value is equal to -1, that means something, right? That means we need to, that was an error, so we're going to want to check for that. Again, really lazy with my pseudocode. If it's equal to 0, that means something else, right? What did that mean? That meant that the server closed its connection, which shouldn't happen, but it can happen. If some error goes wrong, or if my server crashes or something, or if you send me some weird data, I might close the connection. And so that is something you want to check for. And finally, you want to say, okay, if when you sent all that data, was it enough? So you want to compare to say, like, essentially, like, if return value is equal to that, then that means you're done. Great. But if it's not, then you need to go back up and to send more data. But you can't just resend the same data. You're going to have to send from where you sent it last. So my pseudocode's getting now really falling apart here, but something kind of akin to this, where you want to now go to, maybe it'd be better to do it like this, dest plus rv, which that actually works with pointer arithmetic, right? If dest is an array, a pointer to array, then adding some will actually get you further into the index. And so you want to do something like this now in your send, and you'll want to have some kind of while loop probably to keep sending until this condition's true. And so you're going to have to handle that in your send as well. You're going to have to do something kind of similar to that in your receive, because you need to check to see when you've received all the data. One more point I'd like to make, and then I'll finish, I promise. If I go back to this example, so now this is talking about receiving this right here. Okay, so this is a valid option. So that is something that you might receive. You might receive 2 requests in one receive command, and you're gonna have to be able to process that. You might receive, so best case is you receive 1 request in 1 receive. Then it's no different than lab 1, except you have to take off the 11. But that might not happen. That might happen. You might get multiple requests. You might get a request and a half. That might be the hardest one to handle. You might get this, where you get your 11, you get your hello world, and you get 11, and you get some of that other message. So you need to say, hey, let me look at this 11, pull off this, call my callback function, then essentially delete that, go to this, say, okay, 11, say, oh, I don't have 11 yet. Let me go back up and call receive again. And so you'll need to do this over and over again. Because if you call receive one too many times, then it'll be blocking, because you'll be waiting to receive and my server will be waiting to receive, and that won't happen. So you gotta be so careful about how often you call receive. And to that point, I strongly encourage students to only call receive, have one receive call in their whole receive function. It can make sense almost to say, oh, I'm going to receive here, and then, okay, if I don't get all the data, then I'm going to call receive a couple lines down under this condition. I find it best to limit yourself to only one receive, because if you have multiple receive functions, then it's really easy for the logic to end up where you call receive one too many times. So if you have one receive function, that's only point of pain that you can run into. And so you're just careful never to go back up to that point unless you really need to. So try to only have one receive call in your whole, what's it called? I want to get it right. In your whole receive response, TCP client receive response. Only have one socket receive. Now, that's just advice. If you feel like you got it figured out and you have more than one receive, then good for you. But how I did it is only one receive call, and I suggest that's the best way to kind of keep yourself out of trouble. Okay, so hopefully this was helpful to you. We'll talk about this more on Monday when we have time for some questions. But like I said, I would get going on this right away. I would have my my craftsmanship craftsmanship meeting together. Maybe miss something. Maybe there's something that someone in your group like, oh, this made this lab way easier, and that might be helpful to integrate into your lab 2. So I'd have that meeting as soon as possible, and then get going with my lab 2 right away. Just to kind of start outlining. I'd copy over my lab 1's code into my lab 2, just to get you going with the parsing arguments, and then I would start modifying some stuff, to fit the structure and to fit this pipelining. Okay, good luck, you guys. I know you can do it. It's a challenging lab, but it's really awesome. You will feel like you're a master of C programming after this lab because you've done things like Realic, which you probably haven't done yet. You'll feel really good about string pointers to memory and null pointers and moving things around. You'll become an expert on all these things after this lab. So it's a really good feeling once you get done with this lab. Okay, good luck.